In section 8.3, we're looking at equations that can be transformed into quadratic form. So looking at example number 1, we have x to the 4th minus 13x squared plus 36 equals 0. Just as a little reminder, quadratic form is ax squared plus bx plus c equals 0. So what you notice is we have a constant term at the end for both of these. But looking at the quadratic, the middle term, variable x, is then doubled in the first term. So I have an x squared and an x. This looks really similar because we have an x squared in the middle, and then we have an x to the 4th, which is doubled x squared. So what we want to do is we're going to let a variable be equal to that middle letter. So I'm going to let u be x squared. So if I wanted to see what u squared was, I would square both sides. And when I raise a power to a power, I multiply, so I end up with x to the 4th. So I can replace x squared with u and x to the 4th with u squared to turn this into a quadratic that we know how to solve. Once I get my answer, I can always back substitute for the original variable. And so all this does is it allows us to solve something temporarily so that we can actually solve it at the end. So I'm going to rewrite my equation as u squared minus 13u plus 36 equals 0. Now this is factorable on the left-hand side. This factors as u minus 9 and u minus 4. So setting each one of these equal to 0, we have u minus 9 equals 0, and we have u minus 4 equals 0. And so solving for u, we're going to add 9 to both sides. So we get u equals 9. And we're also going to add 4 to both sides. And we get that u is equal to 4. The problem is the original equation was not in terms of u, it was in terms of x. So what we can do is we can go back to our original substitution and we can replace our u with x squared. So we have x squared equals 9 and we have x squared equals 4. Well, I can go ahead and solve this by using the square root property. So I'm going to take the square root of both sides. So we have the square root of x squared is equal to plus or minus the square root of 9. And we also have the square root of x squared equals plus or minus the square root of 4. And so on the left-hand side, the square and the square root cancel and we just get x. And on the right, we end up with plus or minus 3. With the other one, we end up with x equals plus or minus 2. And so we get x equals plus or minus 2 and plus or minus 3 as our final answer. Let's go ahead and try another one. We have x to the 2/3 minus 3x to the 1/3 plus 2 equals 0. So again, looking at that middle variable, x to the 1/3, and x to the 2/3 is double that. So I'm going to let u be x to the 1/3, and so that means u squared would be x to the 1/3 squared, but when I multiply that together, I just get x to the 2/3. So we can rewrite this in terms of u. We have u squared minus 3u plus 2 equals 0. Again, this is factorable, and so we can factor this as u minus 2 and u minus 1 equals 0. And so setting each piece equal to 0, we've got u minus 2 equals 0 and u minus 1 equals 0. And when I add 2 to both sides, we end up getting u is equal to 2. And when I add 1 to both sides, we end up getting that u is equal to 1. But again, the original equation was in terms of x, not u. So I need to go ahead and make the replacement. And so really what we end up having is x to the 1/3 is equal to 2. And we have x to the 1/3 is equal to 1. So to undo the 1/3 power, we just want to raise both sides to the reciprocal, which is 3. So we have x to the 1/3, and we're going to raise this to the 3rd power. But what we do to one side, I have to do to the other. And so we end up getting that x is equal to 8. And then the same idea goes for the other one. We want to raise both sides to the 3rd power. And we end up getting that x is equal to 1. So our final answers are x equals 1 and x equals 8. Let's go ahead and try one more. We have x raised to the -2 equals 5x to the -1 plus 14. Well, with quadratics, we always set them equal to 0 first, and that is the goal, is to make this look like a quadratic. So I'm going to subtract 5x to the -1 and 14 from both sides. So we end up with x to the -2 minus 5x to the -1 minus 14 equals 0. So again, looking at that middle variable, x to the -1, you'll notice that x to the -2 is the double of it. So I'm going to let u be equal to x to the -1. And if I were to find u squared, that would just be x to the -1 squared, which is just x to the -2. So we can go ahead and rewrite this as u squared minus 5u minus 14 equals 0. This left side factors nicely, as u minus 7 and u plus 2 equals 0. We're going to set both pieces equal to 0. So u minus 7 equals 0 and u plus 2 equals 0. So we're adding 7 to both sides. And we get that u is equal to 7. And we're subtracting 2 from both sides. And so we end up getting u equals negative 2. But again, the original was not in terms of u, it was in terms of x. So we're going to replace with our substitution. So we have x raised to the negative 1 equals 7, and we have x raised to the negative 1 equals negative 2. But what does x to the negative 1 mean? Remember, we always flip this over the fraction bar to make it positive. So what we really have is 1 over x equals 7, and 1 over x equals negative 2. So solving for x, I'm going to multiply by x on both sides so that I can get rid of the denominator. We get 1 equals 7x. And then the last step is to divide both sides by 7. And so we get x equals 1/7 as one answer. And we're going to do the same process with the other one. We're going to multiply both sides by x. So it cancels. And we get that 1 equals negative 2x. And we're going to divide both sides by negative 2. So we get x equals negative 1/2. So our two solutions are x equals 1/7 and x equals negative 1/2.